so in this video, we're just going to review some expressions, some equations things, and then a little bit of inequalities, just so that we have everything kind of fresh in our mind before we go to break. Okay? All right, so it says how many terms are in the expression. So remember that a term is a constant, it can be a variable, it can be a variable with a coefficient, but they are separated by adding and subtracting. And I'm gonna write in pencil today. It's got good lighting. All right, so -10 is its own term, plus 9n is a term, minus 3n is a term, and plus 2 is a term. So there's 1, 2, 3, 4 things that I either circled or boxed. Okay. All right, so the next one is like terms. Circle the like terms. Like terms are either going to be they have the same variable or they're both just a constant. So here I see that plus 9n and minus 3n. I guess I didn't circle them. Those are like terms because they have the same variable. Okay. All right, so then simplifying expressions, we're going to combine like terms. So first I'm going to identify what are the like terms. -10 is a term and plus 2 are like terms because they're both constants. So something that you're adding or subtracting to a variable but does not have a variable. So to combine them, I'm just going to take -10. This plus belongs to the 2, so plus 2 is -8. Okay. And then these are like terms because they both have n as their variable. So 9n minus 3n, to combine them, I'm just going to combine their coefficients. 9 minus 3 is 6. So 9n minus 3n is 6n. Okay. All right, and then this one's for simplifying, we're going to distribute. So I'm going to take the number on the outside times each thing on the inside. All right, because I can't combine 3x minus 7. They're not like terms. I can't add them or subtract them. Okay, but I still need to deal with the parentheses, so I'm going to multiply. Parentheses mean to multiply. So I'm going to take -5 times 3x. This minus belongs to the 7. So -5 times -7. Okay. So to do -5 times 3x, I'm going to do -5 times 3, which is -15. So -15x. The -5 times -7 is positive 35. Since it's positive 35, I can put plus 35. And then I stop there. This one has an x. 35 is a constant, so they're not like terms. I can't combine them anymore. Okay. All right, so solving the equation. I'm going to put a line through my equal sign. My goal is to get n by itself. Okay, so I need to make my constant 16. I'm going to circle my constant. I want to make that into a 0. To make 16 into 0, I'm going to subtract 16. On this side, I'm left with n. 24 minus 16 is 8. And then that's where I stop because I got a positive 1 of my variable. So n equals 8 is my answer. Okay. So same thing, r over 13 equals -14. Draw a line through your equal sign. Okay. Right now, r is being divided by 13. The opposite of dividing by 13 is multiplying by 13. Multiplying by 13 and dividing by 13 are opposites. They cancel each other out. And I'm left with a positive 1r. Then -14 times 13 is -182. And that's my answer because I got a positive 1R. Remember that if there's no number in front of my variable, it's assumed to be a positive 1. Right. Next one. All right. So I go through my list of question check marks. Are there parentheses? No. Are there like terms? No. Is there a constant? Yes. So we're going to circle our constant. My goal is to make the constant 0 by doing the opposite. The opposite of subtracting 8 is adding 8. So I'm going to add 8. What I do on the side with the variable, I have to do on the other side. So I'm going to add 8 to both sides. I'm left with y over 2 equals 16 plus 8 is 24. So now I have y over 2 equals 24. So I undid my constant. My last thing I can do is undo the coefficient. Right now, y is being divided by 2. The opposite of dividing by 2 is multiplying by 2. Multiplying by 2 and dividing by 2 are opposites. They cancel each other out. I'm left with y. 24 times 2 is 48. I got positive 1y. I got y by itself. So that is my answer. Y equals 48. So again, draw the line through the equal sign. Negative 20 equals 1 minus 3n. So I'm going to work on this side with my variable. There's no parentheses. There's not like terms. There is a constant. Okay, I have a positive 1. Okay, I want to make my constant into 0. So I'm going to subtract 1. What I do on the side of the variable, I do on the other side. 1 minus 1 is 0. These cancel each other out. I'm left with a negative 3n. Negative 20 minus 1 is negative 21. Okay. So I undid the constant. Now I need to undo the coefficient. My coefficient is negative 3. Negative 3n means negative 3 times n. The opposite of multiplying is dividing. I'm going to divide by negative 3. Negative 3n divided by negative 3 is 1n. Negative 21 divided by negative 3 is positive 7. All right, one more equation. All right, so first I say, are there parentheses? Yes, parentheses mean I need to multiply. So I'm going to take negative 6 times 7k. I'm going to do negative 6 times 7. So negative 6 times 7k is negative 42k. Then I'm going to take negative 6 times 6 is negative 36. So I'm going to do minus 36. Okay. So I took care of parentheses. Okay. There are no like terms. So working from the side of my variable, I'm going to undo the constant, which is minus 36. The opposite of minus 36 is plus 36. What I do on the side of the variable, I do on the other side as well. I'm left with negative 42k. 90 plus 36 is 126. All right, so I undid the constant. Now I need to undo the coefficient, which is negative 42. Negative 42k means negative 42 times k. The opposite of multiplying is dividing. So I'm going to divide by negative 42. You have that k equals negative 3. All right, so we just got like a few more problems. I'm going to try to not go too slow, but not too fast. I don't want this video to be super duper long. Okay. All right, so it says, write and solve an equation to represent the situation. Jay bought four soft pretzels that were $3.50 each, and candies that were 25 cents each. How many candies did they buy if their total was $16.75? Okay. So go through and we're going to circle important numbers and units. So 4 soft pretzels, $3.50, 25 cents, $16.75. So circle your key numbers and units. Now I'm going to underline the question. How many candies did they buy? So underline your question. Then I'm going to box our math action words. I see the word each. Okay, since I'm buying multiple pretzels, I'm going to multiply. I see another each. Again, that's multiplying. Ooh, I see a sneaky one. And that means I'm going to add. And total tells me that's going to be equals. Okay. So I know that the money Jay spent on soft pretzels plus the money that they spent on candy will equal the total amount of money they spent at the store. Okay. So I'm going to pick a variable based on my question. My question is, how many candies did they buy? So let's do C to represent the number of candies. Okay. All right. So to find the money they spent on pretzels, I'm going to take how many pretzels they bought. They bought 4 pretzels times the cost of each pretzel. So that's where this times comes from. So times $3.50. Okay. And so I'm going to add the money they spent on candy. How many candies they bought, we don't know. That's my variable. So C times the cost of each candy, 25 cents. That's going to equal the total amount of money spent. Okay. All right, so now I'm ready to go through and solve. Are there parentheses? Yes. So I'm going to do 4 times 350 is 14 plus 25 cents per candy times the number of candies equals $16.75. So I took care of parentheses. There's no like terms. My constant is 14. To make 14 into 0, you want your constant to be 0. I'm going to subtract 14. I'm left with 0.25c on the left. 16.75 minus 14 is 2.75. Okay, then I need to undo my coefficient. Okay, I'm going to divide by 0.25. Then C equals, so 2.75 divided by 0.25 is 11. They bought 11 candies. All right, one more word problem. At a baking competition, the judges made 4 example cakes that were then cut into 6 pieces. All right, my other pencil died, so I'm going to go back to pen. Wish me luck. The contestants' cakes were also cut into 6 pieces. How many cakes did the contestants make if there were a total of 66 pieces? So I just went through and circled my numbers, and I underlined my question. How many cakes did they make? We're going to say that cut into is an action word. And then also is going to tell me something, and then total. Okay, so I'm going to pick my variable, C, to represent my question. How many cakes did the contestants make? So C is going to be the number of cakes. Okay. So I know that the pieces the judges made plus the pieces the contestants made is going to equal the total number of pieces. Okay. So to find the pieces that the judges made 4 cakes, okay, that were cut into 6 pieces. So if I have 4 cakes and I cut it into 6 pieces, the number of pieces is going to get bigger. So I'm going to actually multiply. So 4 cakes times 6 pieces. Plus, there are 6 pieces for each of the contestants' cakes times the number of cakes they made, which I don't know, so my variable C, equals a total of 66 pieces. Now I'm ready to solve. I have to do parentheses first. 4 times 6 is 24. And draw a line through my equal sign. I have to get rid of the constant first. So whatever I'm adding or subtracting to the variable. So I want to make 24 my constant into 0 by subtracting 24. And I'm left with 6C. 66 minus 24 is 42. Now I have to undo the coefficient. 6C means 6 times C. The opposite of multiplying is dividing. We're going to divide by 6. You can get that C equals 7. 42 divided by 6 is 7. They made 7 cakes. All right. On to inequalities. We're going to graph the inequality A is less than or equal to -1. I'm going to put my circle on -1. And then I'm going to pick test points to figure out which direction my arrow goes. So we're going to try -3. Okay. So instead of A, I'm going to put -3. Is -3 less than or equal to -1? Yes, it is more negative. So the more negative you get, the smaller the number actually is. And you get to color in anything that makes this true. So that works. So I get to color this way. Okay. All right, then we're going to pick our point itself. So I'm going to put in -1. Is -1 less than or is it equal to -1? Yeah, -1 is equal to itself. So that works. So I get to color in -1. So I get to fill in my circle. All right, and then I'm going to pick a point to the right. Let's pick +2. Is +2 less than or equal to -1? No, it is not. So I do not get to color that way. Okay, so anything to the left is going to be less than -1. So I draw my arrow to the left. All right, so we're going to solve this one, then graph it. Okay, I have to undo my constant first. The opposite of +3 is -3. What I do on the side of the variable, I do on the other side as well. I'm left with a -1p. It's greater than or equal. -11 minus 3 is -14. Okay, right now there's a -1p, but I want a +1p. So I'm going to divide by -1. Negative 1 divided by negative 1 is positive 1, so I get a positive 1p. Negative 14 divided by negative 1 is positive 14. Remember that when you multiply or divide by a negative number, negative 1 is doing the dividing. I have to flip the direction of my inequality. So my inequality is actually that p is less than or equal to 14. Okay. All right, so now I'm ready to graph. I'm going to put my circle on 14. Okay. So I'm going to say is 15. So instead of p, I'm going to put in 15. Is 15 less than or equal to 14? No, 15 is bigger. That doesn't work. So I don't get to color in 15. Let's try our point itself, 14. Is 14 less than or equal to 14? Yeah, they're equal. That works. So I get to color in 14. And then we're going to pick one to the left. Let's try 11. Is 11 less than or equal to 14? Yeah, 11 is less than 14, so I get to color it this way. So any number to the left is going to be less than 14. All right, last one. We're going to draw a line under our symbol. To solve, I have to undo the constant. To make 5 into 0, I'm going to subtract 5. What I do on one side, I do on the other side. I'm left with p divided by 5 on the right. Bring my symbol straight down. Greater than or equal to, or less than or equal to. 2 minus 5 is negative 3. Okay. All right, then I'm going to switch colors. You guys see this one? I can kind of see that one. What about this dark green? Those are kind of the same. All right, so now I have to undo my coefficient. Right now my variable is being divided by 5. The opposite of dividing is multiplying. So I'm going to multiply both sides by 5. That gets rid of the 5's. I'm left with p. 5 times negative 3 is negative 15. Okay, and then my symbol comes straight down. Okay. So I multiplied by a positive number. So even though the number being multiplied was negative, it doesn't matter because the number doing the multiplying was positive. So I don't flip my symbol. Okay. All right, so then to graph it, I'm going to put my circle on negative 15. And instead of p, I'm going to pick numbers on my number line. Let's try negative 17. So I pick one to the left of my circle. So is negative 15 less than or equal to negative 17? No, the more negative it is, the smaller it gets. So that is not true. I don't get to color that. We're going to pick our point itself. Is negative 15 less than or equal to negative 15? Yes, they're equal to. Okay, so that equal to part covers me. So I get to color in my circle. And we're going to pick one point to the right. Is negative 15 less than or equal to negative 10? Yes, negative 15 is more negative than negative 10. Since that works, I get to color to negative 10. And I know that any number to the right is going to be greater than negative 15. So negative 15 will be less than those. All right, and there you have it. I know that was long, but this is a review for pretty much everything we've been doing for all of second quarter. Oof, okay. So thanks for hanging in there. Good job.